Hello there, and welcome to Sleepy Cosmos channel. Tonight we are going to ask a question that sounds like it wants a simple answer, and instead hands us something far kinder. What is the largest star ever found in the universe? Out past a certain point, largest stops being a number you could ever hold up and compare, and becomes more like a single thread of light, spun out so far into the dark that no one has ever found where it ends. You are not going to be asked to find the end of it either. You only have to follow the first few inches of that thread, right here, right where you already are, safe under whatever roof is over you now. We have 4 slow regions to drift through tonight, and every one of them is really just another few inches of the same thread. First, we sit right here on ordinary ground and ask what largest star could even mean, turning the phrase over like a smooth stone before we ever leave home. Then we travel, without moving an inch of our actual bodies, out toward a hazy cloud of stars called Scutum, to meet a single giant named Stephenson 218, whose body is so wide that light itself takes hours just to cross from one of its edges to the other. After that, we ease further back and simply watch how a star like this one grows old, swelling, loosening at its edges, breathing in an unhurried tide across untold stretches of time, surrounded by a hushed family of similar giants scattered through the galaxy. And last, we sit with the strange, comforting truth that even the scientists who study this giant cannot agree on exactly how big it is, and that this uncertainty is not a failure of anyone's counting. It is simply what happens when a thing is too vast for a single tidy number, and it is allowed to stay that way. You can let all 4 of those regions go now, right at the start, because I will be the one carrying them for you. There is no test at the end of this. There is only the thread, and your breathing, and the dark. If any part of this helps you find your way towards sleep tonight, a like or a subscribe helps this channel find its way to other people who are also lying awake somewhere, waiting for something enormous and far away to make the room feel smaller and safer instead of larger and stranger. But that is for later, or for never. It changes nothing about what happens in the next few minutes. There is nothing here tonight that you need to hold on to. No fact to remember, no thread to keep track of by yourself. Let your shoulders ease down away from your ears. Let your jaw loosen. Let the mattress or the pillow take a little more of your weight than it was taking a moment ago. Settle in. Let's begin. Let your shoulders sink into whatever is holding you tonight, and let the room fall away by degrees, the way a shoreline falls away behind a boat that never asked to hurry. You are lying beneath a summer sky, the kind that only shows itself fully once your eyes have had long enough in the dark to trust it. Somewhere above you, past the porch light, past the last plane blinking towards some ordinary morning, the sky is arranging itself into old shapes, and low in the south, riding along the thick, pale spill of the Milky Way, there is a small constellation that most people never learn to find: Scutum, the shield. It is not bright. It does not announce itself. It is a modest little kite of stars that a 17th century astronomer once named for a Polish king's coat of arms. And if you didn't know to look for it, you could watch the whole sky wheel past for a lifetime and never notice it was there. And yet, hidden in that unassuming patch of night, tucked inside a haze that looks, to the naked eye, like nothing more than a smudge of fog on black glass, is one of the largest single objects that light has ever carried news of. Not a galaxy, not a nebula breathing out its colors over light years. A star. One star. So vast that if you tried to hold its true size in your mind all at once, the thought would simply slide off, the way a dream slides off the moment you reach for it in the morning. Tonight, you don't have to hold it all at once. Tonight, you only have to lie still and let it come to you slowly. One unfolding at a time, the way the whole sky has always come to anyone patient enough to wait for their eyes to adjust. Most of the stars scattered across your summer sky are small by comparison, pinpricks close enough or bright enough to earn their place in the old pictures, hunters and bears and swans, drawn by people who lay on their backs just like you and needed shapes to hang their stories on. Scuti offers no story like that. It sits low, half drowned in the brighter wash of the galaxy's own crowded center. Easy to overlook even by people who know exactly where to point a telescope. And that quietness feels right, somehow, for what it hides. The largest thing we have ever measured does not sit in some famous, celebrated corner of the sky. It waits in one of the plainest, least remarkable patches of dark, as if size, out here, has never had anything to do with being noticed. So here is the question the title of this night is asking, and it is really a kind of riddle, soft-edged and unhurried, with no wrong answers and nowhere to rush toward. What is the largest star ever found? Not the nearest, not the brightest to your eye. The largest, the one that, if it could be weighed and measured and laid beside all its siblings, would take up more room than any other star we have ever managed to see. Somewhere out past the reach of your ordinary evening, past the neighborhoods of stars you already know by name, there is a giant. And this is the strange, tender heart of the whole story. It is a giant so gentle, it doesn't even know its own size. It has no hard edge to feel where it ends. It has no mirror held up beside it to say, "Look how big you've grown." It has no neighbor close enough, no other star standing near enough at its own towering scale to turn and say, "I see you, and you are enormous." It has simply been growing, quietly, for longer than any human eye has been open to watch it, filling more and more space the way a held breath slowly fills a chest. And nothing out there has ever told it what it has become. Let that sit with you for a moment, because it is the thread we'll follow through everything else tonight. A star that towers, and yet has no way of knowing it towers. Size, out there in the dark, is not something a thing announces about itself. It is something we, tiny and patient and very far away, have had to go and find out, one careful measurement at a time, across centuries. Before we go any further, let's settle something that might otherwise sit at the back of your mind like an unlit lamp. You are perfectly safe here. This whole journey tonight happens only in the soft, borrowed geography of imagination. We are not going anywhere. Your body stays exactly where it is, warm and unmoving, tucked into this ordinary night on an ordinary, small blue planet. The giant star we're going to visit is so far away that its light left home before the pyramids were dreamed of, and it does not know we exist, has no hunger for us, no interest in us at all. It simply glows, alone in its patch of sky, the way it has for a very long time, and will for a long time still. Nothing out there needs anything from you. Nothing out there is coming any closer. We are only going to look, the way you might look up at a lit window in a house far down a dark road, and wonder, gently, what kind of room is glowing in there, without ever needing to knock. And because we're only looking, we can take our time. That's the whole shape of tonight, really. A slow, unhurried walk through one enormous question, broken into pieces small enough to rest inside. First, before we can even begin to travel, we'll need to untangle what the word largest actually means when we're talking about a star, because it turns out that big and bright and heavy are three quite different things, and the biggest star of all might not be the one that first comes to mind. Once we understand that, we'll let the light lead us backward along its own path, out past the familiar stars, out through drifting lanes of dust, thousands and thousands of years into the dark, until we arrive at the giant itself, and stand, only in thought, only in feeling, beside something almost too vast to be called a single object at all. From there we'll come in close, the way you might lean toward a candle to feel its warmth without touching the flame, and we'll learn what a star like this is actually made of at its outer edges. Not solid, not hard, but thin and warm and strangely soft, a body without a true boundary. We'll watch it breathe in its own impossibly slow way, and let that breathing carry us, drifting into the giant's own outer layers, weightless, held. And once we've felt what it's like to be that close, we'll pull back and ask the quieter question underneath all of this. How does anything even grow this large in the first place? What happens inside a star's long, slow life that lets its body swell out to such an unthinkable size, even as its true heart, its core, stays small? We'll meet a small family of these gentle giants, cousins scattered across the sky at different stages of the same unhurried unfolding, and we'll notice, without any fear in it, just how small everything familiar becomes standing next to them. We'll rest inside that smallness for a while too, because it turns out that being small, next to something this vast, doesn't have to feel like being diminished. It can feel like being held. And then, gently, we'll admit something almost nobody says about the record holder for largest star in the universe. Astronomers themselves aren't entirely sure how large it really is. The edge of a giant like this fades outward the way fog fades into evening, with no clean line where the star stops and the dark begins. And every new measurement of its distance has, at different times, made it seem a little bigger or a little smaller than we thought. That uncertainty, too, is part of the peace of it. A reminder that even our knowledge is allowed to be soft-edged, provisional, still settling, the way you are settling right now. And at the very end of the night, we'll walk slowly through the human side of this story, the patient astronomers, the old photographic plates, the space telescopes, the decades of quiet, careful looking that it took for anyone to even notice this giant was hiding there at all. But all of that is still ahead of us, and there's no need to reach for any of it yet. For now, let your eyes stay closed, or half closed, whichever they prefer, and let your breathing find its own unhurried rhythm, the rhythm of someone with nowhere left to be tonight. Because before we can meet the giant, before we can even begin our long drift toward that faint patch of light inside Scutum, there's one small, simple thing worth turning over first, slowly. Like a stone in your palm, what do we even mean, really, when we say that a star is the biggest? What we even mean by biggest is a question the sky has never had to answer for itself, and so let it settle over you the way a question settles, when there is no rush to solve it. Not tonight, not as an exam, just as a small unraveling before rest. Because biggest is really three different words wearing one coat. There is mass, which is simply how much matter a star is built from, how much of it there is to weigh, if a scale that size could ever exist. There is brightness, which is how much light pours out of a star into the dark, whether or not anything is close enough to notice. And there is volume, sheer roominess, the amount of space a star's body actually occupies, and this one, tonight, is the one we are chasing. These three don't line up the way you might expect. A star can win at one and lose at the others entirely, quietly, without complaint, the way a very heavy thing can be small, and a very small thing can somehow take up half a horizon. Take the heaviest star astronomers have found, a blazing point called R136A1, tucked in a nursery of young stars far south in the sky, in a neighboring galaxy close enough to still feel like ours. It carries the mass of more than 200 suns folded into it, an almost unreasonable amount of matter, gathered and lit, burning through its fuel so fast and so fiercely that it will live only a few million years, a mayfly next to our sun's slow, patient 10 billion. R136A1 is dense with itself, compact, furious. If mass alone were the measure of biggest, the crown would rest there, and the story would already be over. But mass is not size, not the way a held breath differs from the air itself. You can pack enormous weight into something surprisingly small, the way a fist holds more of you, pound for pound, than an open, spread hand. Brightness tells its own separate story too. Some of the hottest, bluest stars in the galaxy pour out more light in a single hour than our sun manages in a year. Their surface is so searing that the color blue itself is what heat looks like at that extreme. These are the luminous ones, the stars you'd notice first from far away, the ones that would announce themselves loudest across a dark room, their light reaching you before you'd even thought to look for it. But loudness is not largeness either. A small, brilliant lamp can outshine a lantern the size of a house if the lamp burns hot enough, if it is concentrated enough, if all that fury is packed into a tight, blazing little sphere instead of spread wide and easy. Luminosity, in the end, is only a question of how much light escapes, moment to moment, into the dark. And a star can be almost unbearably bright while still being, by the plain measure of how much room it takes up, rather modest. And so brightness slips out of our hands too. One more definition that almost fits and then doesn't. One more coat that turns out to belong to someone else, which leaves volume. Actual roominess. The measure of a star not by its mass or its noise, but by the honest question, if you had to walk around the outside of it, how far would you go? And this is where the story turns gentle, almost tender. Because the stars that win this particular contest are not the fierce blue ones and not the crushingly heavy ones. They are the cool, dim, red giants and hypergiants. Stars so puffed out, so loosely held together, that despite occupying more space than almost anything else that burns, they glow with a kind of low, patient ember light instead of a blaze. Puffed thin as a held breath, that's the phrase to keep. Because that is what these stars are, matter spread so wide and so lightly that the very hugeness of them is a kind of softness. A star this large has, in a sense, let go of its own density to become vast. It traded ferocity for size, the way a whisper can fill a large room if the room is quiet enough and you are patient enough to hear it. To even talk about a size this large, we need a ruler that isn't built from kilometers or miles, because those units start to feel almost silly out here, like trying to measure a field with a fingernail. So astronomers borrowed the one thing in the sky we already know intimately, the one star close enough to have actually measured properly, and made it the unit itself, our sun folded down, in all its glowing roundness, into a single number, 695,700 kilometers of radius. The distance from its center out to its visible edge, the number packed into the disk that rises over your own horizon most mornings without asking permission. And then, that whole number, that whole familiar sun that warms your afternoons and sets behind your rooftops, becomes just one small unit, one solar radius, a single stitch in a much larger cloth. When we say a star is 100 solar radii, or 1,000, we mean, take the ordinary sun you have looked at your whole life, the one that has never once seemed enormous to you, and imagine 100 of it, laid end to end, reaching outward from where you stand, each one exactly as familiar as the last. It is, in its way, a very kind ruler. It lets the incomprehensible measure itself against something you already, quietly, know. So that even the strangest number tonight still has 1 foot resting on solid, ordinary ground. And here is the part that turns out to be strange in the nicest way. The kind of strange that unclenches something in the chest rather than tightening it. The very biggest stars, by this honest measure of volume, are not fierce. They are not blazing. Per patch of surface, for every small imaginary square of skin you could lay your hand against, if a hand could ever touch a star, the largest stars in the universe are actually among the coolest and dimmest that exist. Their vastness comes not from intensity but from spread, from all that ember-red light being smeared out over such an enormous surface that any single patch of it glows low and slow, almost sleepily, like coals settling after a fire rather than the fire itself. A star that size doesn't need to shout. It has already given up its edges to become large, and in giving up its edges, it gave up some of its heat too. The way anything spread wide enough eventually cools at the surface. The way a large lake stays calmer than a small rushing stream. This is the giant we are circling tonight without yet arriving. A giant so gentle it doesn't know its own size, because nothing about it is sharp enough, hot enough, urgent enough to insist on being measured. It has no hard edge to press against a ruler, no mirror nearby to catch its own reflection back, no neighboring star close enough, in all that quiet reach of space, to lean over and say, "Look how large you've become." It simply is what it is, glowing low and red and enormous, in a stretch of sky most people have never had reason to look toward. And right now tonight, astronomers hold up as the reigning candidate for the largest star ever measured a name that sounds almost like a catalog entry, because that is exactly what it is. Stevenson 218. Sitting at somewhere around 2,150 solar radii, 2,150 of our familiar daylight sun, laid end to end, folded into one body. We won't step inside it yet. We won't measure ourselves against it yet, or feel how far its edge would reach if it sat where our own star sits. For now it is enough to know the number exists, quietly, patiently, waiting in a part of the sky most people never think to look toward, and to know its name and the constellation that holds it and the long, dark distance still between us and it. Because that is where we are going now. Not with a rocket, not with anything urgent, only with attention, the softest form of travel there is, the kind that asks nothing of the body and costs nothing of the night. Somewhere above you, low across the summer horizon, there is a small, faint smear of stars called scutum, easy to miss, easy to mistake for nothing at all. A little shield-shaped patch tucked against the brighter, busier band of the galaxy, the part of the sky most eyes glide right past on their way to something more obviously dazzling. It doesn't announce itself. It has never needed to. Let your eyes rest there anyway, unfocused, the way you'd rest them on a far wall before sleep. And it is toward that unremarkable patch of dark, that quiet fold in the Milky Way, that we now let the light lead us backward, tracing each faint ray to the vast, dim, ember-colored source that has been glowing there, unhurried, this entire time, waiting the way old things wait, without impatience, without expectation, simply present. Let that number rest for a moment, 2,150 of our suns, laid end to end, because a figure like that means little until you have crossed the distance that holds it. So set the arithmetic aside and let the night carry you instead. Low in the summer sky, tucked among fainter neighbors, hangs a small constellation shaped like a modest shield, Scutum. Most people never learn its name. And yet behind that unremarkable patch of stars, inside a haze that looks to the naked eye like nothing more than a smudge of cloud caught on the dark, sits the giant we have been circling all this while. 19,000 light years separate you from it. Say the number and it refuses, at first, to become anything you can hold, so let it become a permission instead, permission to stop counting and start drifting. Imagine leaving the small, bright, close things behind, the moon, the planets, the familiar stars that make up the shapes you learned as a child. Imagine passing out through the thin scatter of stars near home, out past where the sky yet feels personal, and into the long river of light that arcs overhead on a clear night, the hazy band people have called, in every language, some version of a path, a road, a river of milk. You are entering the disk of your own galaxy edge on now, looking along its spiral arms the way you might look down a hallway lined with lit windows, each window a star, each one impossibly far, each one patient in its place. The path toward Scutum runs first through the Sagittarius arm, a curling limb of the galaxy crowded with young blue stars and the warm bloom of stellar nurseries, and then onward, further yet, into the Scutum Centaurus arm, one of the two great spiral arms that wind out from the crowded center of the Milky Way, like the arms of some enormous, unhurried pinwheel. Here the galaxy thickens. Stars gather more densely, with every passing 1,000 light years, packed shoulder to shoulder the way houses crowd closer as a country road leads you toward the heart of a city, and the darkness between them fills in, degree by degree, with something more than empty space. Dust drifts between the stars in long, dark lanes, not the dust of a room, but fine grains of carbon and silicate, the leftover ash of older stars that lived and ended long before the sun was born, scattered so widely and so sparsely across such vast distances that even trillions of these grains, spread across light years, amount to something thinner than the faintest breath of smoke. And yet at this scale, thinness adds up. Light passing through enough of it, across thousands of light years, comes out changed, dimmed and reddened, the way a sunset reddens as its light slants through more and more air. The giant you are traveling toward has spent millennia looking at us through exactly this kind of veil, which is one reason it kept its size a secret for so long. Its true brightness arrives at our eyes disguised, diminished, wrapped in a kind of gauze woven from the dust of stars that came before it. Consider, as you drift through these dust lanes, what the number 19,000 light years actually asks you to believe, that the light now settling into your eyes, if you could truly trace it back, left its source 19,000 years ago on the world you know, that is a span reaching back before farming, before cities, before writing. A time when small bands of humans were pressing ochre and charcoal onto the walls of caves, tracing the outlines of horses and bison and their own open hands by firelight, with no notion that anywhere above them a star was already swelling toward a size no one on Earth would yet have words for. That star's light has been crossing the galaxy this entire time, unhurried, indifferent to empires rising and falling beneath it, arriving now, tonight, precisely on schedule. There is something restful in that thought rather than something dizzying, the universe keeps its own unhurried calendar, one where 19,000 years is simply the length of a single unremarkable errand. Light doing what light does, at its own patient pace, needing no one to wait for it, and yet arriving anyway. Whole civilizations rose out of those cave painting bands and dissolved back into soil, while this one beam of light was still only partway across the galaxy, unconcerned, unaware it was carrying tonight's small miracle toward a species that had not yet learned to write its own name. You do not have to catch up to it. It has already come to you, patient the whole way, asking for nothing in return but a pair of eyes willing to look up. Deeper into the arm now, the dust thickens further, drifting in long dark ribbons that curl and overlap the way silt curls in a river when you drag a hand through it, and the stars ahead begin to blur and swim, their light softened at the edges the way a lamp looks through a window on a foggy evening. These dust lanes are not obstacles so much as veils, sheer and layered, each one dimming what lies beyond it a little further, so that a star burning as fiercely as any other might reach your eyes looking faint, muted, half-hidden, simply because of how much veil it had to cross. This is the outer skirt of the Stephenson 2 cluster, though you would not yet call it a cluster from here. Only a faint thickening in the haze, a place where the dark seems to hold more light than it should. Somewhere nearby, decades ago by our reckoning, an astronomer scanning infrared images noticed exactly this: a small, dense gathering of stars glowing far too red and far too bright for their apparent size, hidden behind dust that ordinary light could never fully penetrate. Infrared light, with its longer, lazier waves, slips through interstellar dust the way a low note slips under a door that stops higher, sharper sounds. And so it was infrared eyes, not ordinary ones, that first caught this cluster hiding in plain sight, tucked into the crowded galactic disk toward Scutum, waiting quietly to be noticed. Push in closer, and the fog begins, at last, to organize itself. What looked like a single smudge resolves, point by point, into individual embers, not the sharp white or blue of nearer stars, but a deep, banked red, the color of coals rather than flame. This is the hallmark of the cluster you are entering. An open cluster, a loose family of stars born together from the same collapsing cloud of gas, drifting through space in each other's company, though not bound tightly enough to stay together forever. And scattered among its ordinary members are these embers, red supergiants, stars that have already burned through the fuel that once made them blue and fierce, and have swollen instead into something vast and cool and hushed. One cluster, holding more red supergiants than almost any other region known in the galaxy. Each one a giant in its own right, each one glowing low and steady like a lantern left burning through the night for whoever might be traveling this way. You drift among them now the way you might walk into a garden at dusk and find fireflies rising one by one out of the dark. Except these lanterns do not blink, they simply glow, patient and unmoving on the timescale of a human life, though each is a churning, breathing world of gas and radiation on the timescale that belongs to stars. Some of these lanterns are large, a few are larger yet, and then, past the others, past even the brightest of its bright red neighbors, one lantern begins to fill more and more of the view, its light spreading wider than seems reasonable for something so far away, its ember red glow deepening as it grows, until it is no longer one light among many, but the only light that matters, swallowing the foreground, swallowing the frame entirely. Stephenson 218 itself, the giant you crossed 19,000 years of light to find, opening in front of you now like a door made of warm, dim fire so wide it has almost forgotten it has any edge at all. Whatever it is you expected a record holder to look like, hold that expectation loosely, because nothing about what fills the view ahead announces itself the way a monument might. There is no hard boundary here, no sharp architecture, no gleam of reflected light off some vast curved hull. There is only glow, soft, ember-colored, spreading outward and outward, until distance itself seems to lose its meaning. A giant so unassuming in its enormity that if you did not already know its name, you might mistake it for nothing more than a low red haze at the heart of its own private fog. And that, it turns out, is exactly the point. A giant this large, wrapped in light this faint and this diffuse, has no way of knowing its own size at all. It has never once seen itself whole. Tonight, drifting closer still, you are about to. And here it is, filling the view the way a lantern fills a paper screen from behind. Not sharp, not blazing, just enormous and warm and close, though it is nowhere near close at all. This is Stevenson 218, the one the whole night has been walking toward, and now that you are here, you can let the number arrive without any need to hold it tightly. About 2,150 solar radii. Let it sit beside you the way a large fact sits beside a small listener, patient, unbothered, in no hurry to be understood all at once. You already know the ruler tonight is using. That folded length, 695,700 kilometers, the whole reach of our own familiar sun tucked into a single unit of measurement. Now take that unit and lay it end to end, over and over, more than 2,000 times, spanning outward from a shared center in every direction at once. There is no need to do the arithmetic in your head. The number is only here to be felt, the way distant thunder is felt as a low presence in the chest long before it is ever counted in seconds. What matters is simply this: you are approaching something that makes even the sun, that vast daily fire, feel almost modest by comparison, and still nothing about it is reaching toward you. It only glows, unaware, in its own patient dark. Picture it the simplest way there is. Take the star nearest to you, the sun that warms your own days, and set this giant down exactly where the sun sits now, at the center of everything you know as home. Mercury, the little quick world, would already be inside it, its whole tight orbit swallowed before it ever began. Venus follows, gone into the glow. Then Earth, this Earth, the one holding you right now in whatever room or field or bed you are actually lying in, folded inward, its entire yearly path erased into the body of the star as easily as a breath disappears into a much larger room. Mars goes next, the red one, absorbed the way a single grain of sand disappears into a returning tide, and still the giant is not finished. Jupiter, the largest of the planets, the one so big it has its own small family of moons, its whole vast orbit vanishes too, taken in without any strain, without any sound. Only past that, past even where Jupiter used to circle, does the giant's surface finally begin to run out of room, its outer skin drifting somewhere near the old path of Saturn, before it finally, softly, gives way to space again. Try, if it helps you drift, to feel the scale in something other than numbers. If you stood, only in imagination, only for a moment, because nothing out there is asking anything of you, at the very center of this star, and a beam of light left that center, and simply traveled outward and around the star's own vast waistline, tracing its full circumference, that beam would still be traveling nearly 9 hours later. 9 hours of light, moving at the fastest speed anything is permitted to move in this universe, just to make one lap around the giant's own outline. You could fall fully asleep, dream a whole dream, wake again, and light would still be out there tracing the edge of this one body. There is something almost funny in that, in a hush way, a thing so large that light itself has to be patient with it. And yet, here is the turn. The one the night has been leaning toward. For all that size, for all that room it takes up in the dark. Stephenson 2:18 is not heavy the way a giant is supposed to be heavy. It is not dense, not crushing, not the kind of vastness that presses down. Its outer layers, the very skin you have just watched swallow whole worlds, are thinner than the air resting against your own skin right now. Thinner than the air over your bed. Thinner, even, than the wisps of cloud a bird might pass through without noticing. If some impossible hand, yours, say, in a dream where distance and danger simply do not apply, reached toward that outer mist, it would pass through with no more resistance than reaching into steam rising from a cup. Warm steam, faint steam, a breath of something that used to be gas and is now barely more than the memory of gas, drifting outward in a hush so complete it barely counts as substance at all. This is the strange, tender secret at the center of the giant stars. The biggest of them are, in a very real sense, the least solid. A star like this holds an almost unbelievable amount of matter, and yet it has stretched that matter across so much space that what remains at the surface is little more than a held breath, spread thin, spread patient, spread wide enough to lose nearly all of its density along the way. You could, if the laws of the universe allowed such visiting, drift into that outer mist the way you might drift into a warm fog rolling off a summer field at dusk, and it would simply part around you, unbothered, asking nothing, offering only its low ember light. There is a small, comforting arithmetic hidden in that thinness, if you want it, though you are free to let it pass by unweighed. A body of ordinary matter, packed the way rock is packed, or even the way air is packed close to the ground, would never be able to spread this far and still hold together. But a star is not held by packing. It is held by its own gravity pulling gently inward, and its own warmth pushing outward, the two forces resting against each other in a long, easy balance. And when a star like this one grows old and swells, that balance simply relaxes into more room. The same handful of matter that once sat close and dense around a young, tight core now lies scattered thin across a volume 10 billion times larger than the one it started in, not crushed, not violent, only unfurled, the way a held breath unfurls into a much bigger room the moment it is finally let go. And that light, that is its own kind of tenderness, where a hot young blue star burns fierce and sharp and nearly unbearable to imagine directly. Stephenson 2:18 glows at a mere 3,200 degrees on the Kelvin scale, which sounds enormous only until you set it beside other stars and notice how far down the register it truly sits. In the vocabulary of stars, this is a low flame, almost a coal at the end of a long fire, cooler at any single patch of its surface than the visible heart of a candle glimpsed up close. It burns not white, not gold, but a deep, unhurried ember red, the color of the last light left in a fireplace long after everyone else in the house has gone quiet. A giant, glowing the color of rest. So hold both truths together now, the way you might hold two thoughts at once just before sleep takes you. Unimaginably large and unimaginably soft. vast enough to erase 5 worlds and still keep reaching, and yet so thin at its edges that its own light can barely warm anything by the time it reaches that furthest mist. This is the shape of the thread running through tonight, a giant so gentle it does not know its own size, because a body this diffuse has no firm edge for anything to feel, not even itself. Where does mist end and night begin? Where does breath end and air begin? The star has no clean line to answer that with, no boundary crisp enough to tell it, here, this is where I stop. It simply fades, the way falling asleep fades, the way a held note fades into silence, without any single instant marking the end of the sound. Somewhere in that endless soft fading, the giant simply is, without ever needing to measure its own outline. Lean in a little closer now, in the safe way that imagination allows, past the outermost hush of that ember mist, close enough to notice something you could not see from farther out. The surface is not still. It is not a smooth, painted skin the way a full moon looks smooth from your window, its edge drawn once and left that way forever. It moves, it shifts, low and unhurried, in patches and swells. Whole regions of that ember-red mist rising a little and settling again. The way a sleeping chest rises and settles beneath a blanket, so faint an outsider might mistake it for stillness at first glance and only later notice the pattern underneath. There is no rush anywhere in that motion, and no wonder. A body this large has no reason to move quickly, no small urgent muscle demanding a fast answer. It simply turns over at its own enormous pace, patch by patch, the whole vast red skin of the giant rising and settling like something breathing in its sleep. You could watch a long time and never catch it changing, the way you can watch clouds a long time and never catch the exact moment one shape becomes another. And yet it is changing, always, underneath the appearance of calm, a body so large that even its breathing takes seasons instead of seconds. That breath, patient, unhurried, older than your oldest memory, is where the night wants to carry you next, in close past watching, into the drifting itself. And now that you are close enough to watch it, you notice the surface is not a surface at all, not the way a stone has a surface, not the way water meets air in a single clean line. What you are watching is closer to weather. The whole outer skin of the star is tiled in convection cells, and each one is a bubble of hot gas rising from somewhere deep and unseen, cresting into view and sinking again to make room for the next. On our sun, these cells are modest things, each one smaller than a country, thousands of them freckling the surface at once, each finishing its rise and fall within about 10 minutes. Here, on this giant, there might be only a handful of cells across the whole visible face, and each one can span a meaningful fraction of the star's entire width. A single rising bubble here could be wider than the distance from our sun to Jupiter. And it does not hurry through its 10 minutes. It takes months. Some take years. You watch one cell brighten at its center as fresh heat wells up from below. Watch its edges begin to cool and darken as the material finishes its arc and starts to sink. And by the time it has finished its slow turnover, whole seasons have passed on the world you left behind to come here. There is no clock ticking inside this. There is only turning. Heat rising because rising is what heat does when nothing holds it back. Gas cooling because giving up warmth is what gas does at the top of any long climb, and then sinking, unremarkably, to be warmed again and rise once more. It is the same principle that stirs a pot on a stove, or that lifts a thermal beneath a hawk's wings, playing out on a scale so vast that a single cycle outlasts a human season. If you let your eyes soften and simply take in the whole face of the star at once, rather than following any one cell, what you see is closer to a slow tide than a boil, regions dimming and regions kindling, the balance shifting a little at a time. No two moments quite the same, none of it sudden. Picture the underside of a cloud bank at dusk, lit unevenly from within, patches brightening as the sun finds a gap, and dimming again as it passes behind thicker vapor. And now stretch that image until each patch is wider than a solar system, and let the whole scene hold its shape, not for a passing minute, but for the length of a year. That is closer to what a distant watcher would see turning across this star's face. No seams, no sharp boundaries between one cell and the next. Only a mottled ember glow, shifting its pattern the way embers shift in a hearth long after the flame has gone. Each glowing patch surrendering its place to the one beside it without any hurry at all. A being that lived a single human lifetime beside this star would see, at most, a few dozen of these great cells complete their rise and fall. It is a patience that makes our fastest weather look like a flicker. Because the whole star breathes the same way its patches of surface do. Step back far enough, and you'll notice its glow is not fixed. It swells a little, fades a little, swells again, on rhythms that don't repeat cleanly, the way your own breath never falls in a perfect metronome even while you sleep. Astronomers who have watched stars like this one for years describe it as irregular variability, a term that sounds clinical until you understand what it is pointing at. A body so large that its own outer layers rise and fall like a chest, in and out, without any two breaths being quite identical. Some of that pulsing comes from the convection cells themselves, their comings and goings adding brightness here and taking it away there. Some of it comes from deeper still, from slow pressure waves moving through the star's outer body the way a low note moves through a held breath, changing the star's radius by a small fraction and its glow along with it. None of these motions are violent. None of them ask to be noticed. They simply happen, over and over, on a timescale too patient for anything but starlight and stone to keep pace with. If you could somehow chart that faint brightening and dimming on a page, stretched across enough years, it would not look like a heartbeat's tidy spike and fall. It would look more like the outline of a coastline, ragged and unrepeating, each little rise its own shape, none quite mirroring the one before it, and yet all of them belonging, unmistakably, to the same shore. And all the while, something even quieter is leaving. A star this size holds its outer layers with a grip so faint it is almost a formality. Down at that ember-colored surface, so far from the crushing density of the core, the pull of gravity is a fraction of what you would feel standing on the sun or even on the earth, thinned out. The way any pull thins with distance, and this outer skin sits at a distance that leaves it barely tethered at all. So the outermost wisps of the star don't need much encouragement to drift away. A steady stellar wind lifts them, particle by particle, out past whatever boundary you might have called an edge, and carries them into the space around the star. It isn't a storm. There is no violence in it, no explosion, nothing you would call a loss in the way we usually mean that word. It is closer to breath fogging on a cold morning and simply not returning to the mouth that made it, present, then gently dispersed, then gone, with nothing dramatic marking the moment of parting. Add up that drift across enough centuries, and the numbers become almost hard to hold. Over tens of thousands of years, a star like this one can shed something like the mass of our entire sun, not all at once, never all at once, but as a long, unhurried exhale, the same handful of atoms leaving now that were rising and sinking in those convection cells a season ago. And that departing material, does not vanish. As it drifts outward and cools, away from the star's ember warmth, some of it begins to condense, atoms finding each other, clustering, forming the tiniest grains of solid matter, motes of dust no larger than smoke, drifting out into the dark around the star, like the last visible trace of a long breath in cold air. This dust becomes part of the surrounding nebula, part of the wider cloud of gas and grain that fills the space between stars, and in time, a span of time longer than a mind can comfortably hold, some of that same dust may gather again, cool and patient, into the beginnings of new worlds. Planets, perhaps, forming out of the very material a giant once carried on its outermost breath and let go of without a second thought. The star that seems to be only losing itself is, in its own unhurried way, also planting something. What is remarkable, if you sit with it, is how little any of this costs the giant in urgency. It is not straining to hold on to its outer layers, and it is not straining to release them either. It simply exists at a scale and a lightness where holding and releasing look almost the same from the inside, where the grip was always so faint that letting go barely registers as an event at all. The giant gives itself away the way a candle gives away its wax, the way an evening gives away its warmth to the coming night, so gradually that there is no single moment you could point to and say, "There. That is when it happened." There is only the long accumulation of countless small partings, none of them noticed by the one doing the parting, each one folding into the next until whole eons have passed and the star is technically smaller than it once was, and it never knew. You have been watching all of this from a small, respectful distance, the way you might watch the sea from a cliff, near enough to feel its scale and far enough to stay dry. But there is another way to be near a thing like this, and it doesn't require watching at all. It only requires letting go of the need to stand apart from what you're looking at. So let the distance close, just for a while. Let yourself stop observing the breath of the giant from outside its rhythm, and instead, imagine slipping into that same rhythm, weightless, carried the way the rising gas is carried, asking nothing of the motion, but to be moved by it. There is nothing to hold on to out here, and for once, that isn't a problem to solve. It's an invitation. And because the giant has been giving itself away for so long without ever noticing, a little more mist released into the dark with every season that turns, you no longer have to watch it from outside. You can stop standing at a polite distance, arms crossed against the cold, eyes narrowed at something so far off it might as well be a rumor. You can let go of the shape you've been holding it in. Let the picture soften. Let the edges you drew around it in your mind blur back into the fog they were always made of, and drift forward, past the place where looking ends and being ends, into the mist itself. There is no threshold to cross. That is the first thing you notice, or would notice, if noticing were still the kind of thing you were doing. No membrane, no wall, no shimmering skin to press your palm against and feel it resist. One breath you are outside the giant, watching its ember light from far away the way you might watch a lamp through a window on a winter road. The next breath, without any seam between them, you are inside its outer air, and the light is not something you are watching anymore. It is something you are in. The gas here is thinner than the thinnest mountain air, thinner than the last high breath before a summit, thinner than anything that has ever had to hold you up. It could not hold up a feather. It does not try. There is nothing to fall through, because there is nothing solid to fall away from. Only a long, unhurried thinning, layer folding into layer, each one so close in density to the one before it that the whole idea of falling stops making sense. You are simply here, suspended, the way a mote of dust is suspended in a shaft of afternoon light. Not because anything is gripping it, but because nothing is pulling hard enough to insist. The warmth arrives from every direction at once, not a wind, not a draft with a source you could turn and face, a temperature that simply is. The way the warmth of a bath is not coming from anywhere in particular by the time you have settled all the way into it. This is an ember warmth, low and deep and red, the color of a coal an hour after the fire has stopped needing tending, the color of light behind closed eyelids when you turn your face toward a lamp you've decided not to look at directly. It touches your skin, if you still have a sense of your skin at all, the way late afternoon touches the side of a house, patient, thorough, without any hurry to finish. This is starlight, but it does not push. Whatever pressure it carries is so faint, so evenly spread across so vast a space, that it does no more than lean, and you are rocked. That is the word for it, the only word that fits. Because nothing here moves the way things move where you come from. Somewhere far beneath you, though beneath has gone soft as a direction too, more a feeling than a fact, vast slow currents are turning over. Bubbles of warmer gas, the size of countries lifting from the deep interior toward the surface, cooling as they rise, sinking again once they've given up their heat, over and over, the whole star breathing in a rhythm too large for a single night to hold. A bubble that begins its climb in one season does not crest until another has arrived to meet it. You cannot feel the size of any one of these currents. You are far too small a thing, adrift in far too large a motion. But you can feel their patience passed down into you, the way a boat far out on a slow swell doesn't feel the ocean's whole vastness. Only the unhurried lift and settle of the water directly beneath it, over and over, 10 seconds up, 10 seconds down, until the body simply agrees to be moved. There is nothing to hold here, and this is the part worth lingering on, the part your mind may need a moment to accept. There is nothing you need to hold. Nothing to grip, no rope, no rail, no edge of anything to keep between your fingers in case the world tips. You have spent so much of your life gripping things, without ever quite deciding to. The edge of a chair on a plane during turbulence, a blanket pulled tight to the chin, your own held breath at the top of a worry. Here, none of that is asked of you. The mist does not require your effort to keep you afloat inside it. It simply is thin enough, and vast enough, and even enough in every direction, that up and down have quietly resigned, and floating has stopped being a thing you do, and become a thing that is simply, continuously, true about you. Notice how the giant itself is held the very same way. Nothing is gripping its outer layers either. No shell, no lid, no strong hand clenched around all that ember-colored air, keeping it from drifting off into the dark. The star's own gravity out here, at the very top of a body this swollen, is almost nothing. A whisper of pull so faint it can barely keep the lightest gases from wandering off entirely, and some of them do wander, drift outward a little further with every slow year, unnoticed, ungrieved, the way you might let a held breath go without ever deciding to. The giant holds its own atmosphere the way it is now holding you, loosely, without gripping, trusting the whole vast slow arrangement to stay roughly where it is, simply because nothing is in a hurry to leave. Let yourself rise with one of those currents, if it's easier to imagine it that way, not climbing. Nothing so effortful as climbing, only being carried the way a leaf is carried by water it never asked to enter. The ember light thickens almost imperceptibly the higher the current takes you, then thins again as it turns and begins its long fall back toward whatever counts as the center of a body with no firm edge to call a floor. Up here, turbulence does not feel like the turbulence you know from the small, fast world. No jolt, no shudder, no sudden drop that snaps you awake. It is turbulence in slow motion only, the kind of disturbance that takes a whole season to become a difference you could notice. So gentle in its unfolding that your body reads it not as motion at all, but as something closer to a held, ongoing sway. The sway of something enormous rocking something very small without ever quite meaning to. You could stay in this for a long while. There is no clock out here, no obligation waiting on the other side of the mist, nothing keeping time except the slow tide of gas rising and falling beneath you, and the fainter, farther tide of your own breath finding the same unhurried rhythm, because bodies tend to borrow the pace of whatever is holding them. Your shoulders, wherever they are now, have stopped remembering that they were ever raised. Your jaw has stopped remembering that it was ever set. The ember light does not change quickly enough to ask anything of you. No flash, no flicker demanding your attention. Only the barest, slowest brightening and dimming. On and on. The star breathing the way it has always breathed, long before you arrived, and long after you will have drifted off from this thought entirely. And somewhere in that drifting, half inside the mist and half inside your own closing eyes, a small, soft question rises the way the bubbles rise beneath you. Without any effort at all, how does anything ever come to be this large? Not a demand for an answer. You are far too warm, far too held for demanding anything. Just a loose, unhurried wondering, the kind that floats up right before sleep and doesn't require you to stay awake for the reply. How does a single body come to hold a whole small solar system's worth of room inside itself, layer by ember layer, breath by slow breath, until distance itself forgets where it was supposed to stop? Somewhere back along the star's own long life, before it ever grew this wide, before it ever learned to breathe like this, it was something else, smaller, brighter, tighter around its own center, and something happened to loosen it, the way sleep loosens a body that has spent all day holding itself upright. That story is still there, waiting on the other side of this floating hush, and you can let it come find you, slowly, the way everything out here arrives. For now, though, there is only this, the ember light on every side of you, the long, unhurried tide of gas lifting and settling far beneath, and the giant itself wrapped around you like a room with no walls, never once asking to be understood before it agrees to hold you. It does not need you to measure it. It does not need you to know how many small worlds could be set inside its width, or how many hours its own light would take to circle once around its own vast waste. All of that can wait for the part of you that likes to count and compare and name. The part of you that is here now, adrift in its ember-colored breath, needs none of it, only the rise, the pause, the long soft fall, and the rise again, borrowed from a body too large to ever feel its own weight, too gentle to ever grip what it carries. Carried still, rocking on that season-long tide of rising and falling light, you find yourself wondering, in the unhurried way a half-asleep mind wonders, how anything ever came to be this large. Not the number, you have already let the number go, but the becoming. How does a body get so wide that light takes the better part of a night to walk around it? The star does not answer in words. It answers the way it answers everything, by simply continuing to be exactly what it is, while somewhere far beneath the mist you are floating in, A much smaller and much older story explains it. Every red hypergiant begins its life as something almost unrecognizable, a hot, blue-white star, dense and compact, burning through the hydrogen at its core with the kind of appetite that only the most massive stars have, where a star like our Sun will sip at its fuel for 10 billion patient years. A star born 8 or 10 or 20 times heavier spends that same fuel in a handful of million years. A mere afternoon by the calendar of the universe. It burns bright, burns blue, burns fast. And then, quietly, the hydrogen at its very center begins to run out. This is the hinge on which the whole transformation turns, and it happens so far inside the star that nothing on the outside notices at first. With the core hydrogen spent, the center of the star can no longer hold itself up against its own weight, and it begins to contract, pulling inward, growing denser, growing hotter. The way a hand closes slowly into a fist. That contraction lights a new fire. A shell of hydrogen just outside the shrinking core catches and starts burning in its place, wrapped around a heart that keeps tightening beneath it. And here is the strange, gentle physics of it. That inward squeeze at the center pushes an equal and opposite sigh outward through the rest of the star. The outer layers, no longer held in the same tight balance, begin to swell. Not by a little. Over time, by hundreds of times their original width, the whole envelope of the star loosening and spreading and cooling as it goes, drifting from searing blue-white toward amber, and finally toward the deep ember-red glow you have been floating inside of all along. So the star you are resting in tonight is really two stars living as one. Deep at its center is something small, ferociously hot, almost unimaginably dense, a heart no larger, in some cases, than a modest world, doing the hard, quiet labor of holding the whole structure together. And wrapped loosely around that heart, spread thin across a distance that would swallow the orbit of Saturn, is the body you can feel around you now, warm, faint, diffuse, so far from its own furnace that it has cooled into something closer to mist than fire. The heart and the body have almost nothing in common anymore. The heart stays small and dense, and stays that way for as long as the star lives in this stage. The body balloons outward, further every age, indifferent to its own edges. And because the part of the star that does the swelling is so far removed from the part of the star that does the burning, there is a real sense in which the giant never feels itself grow at all. Its center goes on with its private, contracted business, entirely unaware that somewhere far above it, its own skin has drifted out past where 5 planets could once have stood in a neat and tidy row. Inside that widening body, other shells may follow, one lighting after another as the core keeps tightening beneath them, helium giving way in its turn the way hydrogen once did, each new fire a fresh reason for the outside to loosen a little further. None of it is violent, not from where you are floating. It is closer to a long exhale than an explosion, layer after layer easing outward, taking its own good time, cooling a shade with every step it takes away from the center. A star built this way does not need to notice its own transformation to complete it. The swelling simply happens, the way a bruise spreads beneath skin without needing permission, patient and total, and entirely without drama. You are not alone tonight in resting inside a body like this. The sky keeps a whole quiet family of these gentle giants, each one a little further along the same unhurried road, each one grown from its own version of that same hidden hinge, a contracting heart, a loosening body, a slow forgetting of scale. Lift your gaze, if you like, though you need not move at all to do it, toward the shoulder of the great hunter Orion, where a star named Betelgeuse glows with that same low ember warmth. Betelgeuse is younger in this stage than the giant carrying you now, smaller by comparison, and yet it could, even now, reach out and cover the orbit of Jupiter if it stood where our Sun stands. It breathes the same way, swelling and easing, brightening and dimming across months, its own outer layers thin enough to ripple. Its light reaching your eyes tonight after a journey of some 600 years, patient and unremarkable to the star itself the whole way. Further on, low and often overlooked, there is a star the astronomer William Herschel once found so richly colored that he simply called it the Garnet Star. Mu Cephei to the charts. A deep red giant swollen wide enough to hold the same easy, borderless glow. Its light arriving warm and rust-toned the way the last coal in a hearth glows before it finally goes dark. Except that this coal has been glowing that way for longer than anything human has kept a record. And there are cousins wider yet. Viconis Majoris, one of the largest stars ever measured in its own right, so vast that if it traded places with our Sun, its outer mist would reach out past the orbit of Saturn, and shedding so much of itself into space that it wears a faint nebula of its own making. Wrapped loosely around it like a shawl it forgot it was wearing, arcs and loops of its own cast-off breath drifting outward in the dark. Animal Cygni, tucked into the constellation of the Swan, glows with that same patient red and swells nearly as wide, veiled behind enough interstellar dust that for a long while astronomers weren't entirely sure how big it truly was. One more giant content to be estimated rather than pinned down, its true edge lost somewhere in the haze it breathes out around itself. None of these stars asked to become this large. None of them decided anything. They simply followed the same patient arithmetic that every star follows once its core hydrogen runs low, contract at the center, swell at the surface, cool as you swell. Each one arriving at its own particular width, the way a river arrives at its own particular bend, by following the shape of what came before it, not by reaching for a record. And even the small, familiar star that warms your own days will someday walk this same road. Though not for a very long while yet, some 5 billion years from now. An unhurried distance so vast it barely deserves to be called a future at all. When that time comes, our Sun's core will contract in the same way, its outer layers will loosen in the same way, and it too will swell into a red giant, reaching out perhaps as far as the orbit of Earth, glowing the same deep ember color, breathing the same slow breath. It will be modest by the standards of the giant holding you tonight, a few hundred times its current width rather than a couple of thousand, but it will be family all the same. One more heart contracting quietly, while a body loosens around it, unaware of its own new size. Held here, drifting among cousins so much larger than anything you have ever stood beneath. It is easy to feel how small the achievements of an ordinary day become. A room, a horizon, a whole planet, all of it fitting inside a fraction of a single breath these stars take. Every worry that felt large enough to keep you awake an hour ago could be folded 1,000 times over into the space between this star's contracted heart and its outermost mist, and yet leave room to spare. But that smallness carries no sting tonight. There is nothing here that asks you to measure up to it, nothing that notices you at all, nothing that would judge the distance between your size and its own. The giant does not know its size, and it has never once needed you to know yours. What is left, once the comparison falls away, is simply scale. Vast, patient, undemanding scale, the kind that, when you let yourself sink into it long enough, starts to feel less like distance and more like a place to rest. one more step down into something smaller, softer, and closer to sleep than the step before it. And that smallness, once you stop resisting it, turns out to be the kindest arithmetic in the sky. So let's do the sum properly, the way you might count sheep. Except every sheep is a whole world, and every fence is a threshold you're allowed to step through without fear of what's on the other side. Begin where your body already is. Earth, this ordinary blue stone spinning quietly under the same night you're lying beneath right now. Now imagine folding 1,000,000 Earths into the sun, not stacking them like bricks, just letting them dissolve into that one warm sphere, the way sugar dissolves into tea until you can no longer find the separate grains. 1,000,000 of your whole world, and the sun barely notices the addition. That's the first step down. Your entire planet, with its oceans and its mountains and its 5 continents of noise and light and worry, is a grain of sugar in a cup the sun is quietly stirring. Now take the sun itself, already so vast it could hold 1,000,000 Earths without complaint, and ask it to step inside Stevenson 2:18, not once, not a few hundred times, 10 billion times over. 10 billion suns, each one already large enough to swallow 1,000,000 worlds, folding into the ember-lit body drifting in Scutum. The number stops being a number almost immediately. It becomes a kind of hush, a place where counting gives up and simply bows. You don't have to hold that figure in your mind and understand it. Nobody does. Even the astronomers who write it down feel it slip through their hands like warm sand. You're only meant to feel the shape of it, an enormity so far beyond your own scale that it loops back around into something oddly restful. The way looking up at a truly dark sky makes your worries seem small enough to set down for the night. And here is where the thread pulls tight again, the one that's been running under this whole journey, a giant so gentle it doesn't know its own size. Stevenson 2:18 does not measure itself against the sun. It doesn't hold a mirror up to its own vastness and marvel. It simply is, breathing its slow ember light into the dark, unaware that 10 billion of something smaller could fit inside it, unaware that it has become, in our small human ledgers, a record holder. Size is our word for it, our need, our way of making sense of something that has no need to make sense of itself. The giant floats past all of that, entirely unbothered. But even 10 billion suns is not the end of the counting, because Stevenson 2:18, for all its almost unthinkable volume, is itself only a single point of ember-colored light among the great turning wheel of the Milky Way. Somewhere between 100 and 400 billion stars share this galaxy with it, a number so loose that astronomers shrug at both ends of it, the way you might shrug at guessing the grains of sand in a single cupped handful. Stevenson 2:18 is one of those grains. The star that could swallow 10 billion suns is, from the vantage of the galaxy itself, no more than a single soft spark drifting in a river of other sparks, indistinguishable in its faintness from 1,000 quieter neighbors unless you know exactly where to look. Sit with that for a moment, because this is the part of the arithmetic that matters more than any of the numbers. Every step down in scale you've just taken, Earth into sun, sun into hypergiant, hypergiant into galaxy, is not a step toward insignificance. It's a step deeper into rest. Each time something you thought was vast turns out to be small beside something vaster, a little more weight lifts off your shoulders, because it means less and less is actually asked of you. You are not required to be the biggest thing in the room. You were never required to be. The sheer scale of what's out there, once you let it in gently instead of flinching from it, does the opposite of shrinking you. It excuses you from ever having to carry the whole weight of importance alone. Think of how a very young child feels inside a parent's arms, lifted at the end of a long day, too small to reach the table, too small to open the heavy door, too small to do almost anything the grown world requires, and how none of that smallness feels like a wound. It feels like the opposite. It feels like being held, rather than being diminished. Like the size difference is not a measure of how little the child matters, but a guarantee that something larger and steadier is doing the holding, so the child doesn't have to. The child doesn't lie awake calculating the difference between their own small weight and the weight of the arms around them. They simply let the difference do its work. Let it become the very reason sleep comes so easily. That's the arithmetic tonight is offering you, scaled up until it includes stars. You are not small the way something forgotten is small. You are small the way something cradled is small. Small enough that the vast dark around you isn't a threat, it's simply room enough to rest in. Consider, too, how differently the same fact can land depending on which way you're facing when you hear it. Told one way, you are a speck on a speck, adrift among hundreds of billions of stars in a single galaxy that is itself only one among countless others. The fact can feel like being erased, like the room getting larger while you get smaller and smaller inside it until you vanish from your own attention. But told another way, facing the other direction, the very same fact becomes an unburdening. If you are only a spark among 400 billion sparks, then the outcome of tonight, of tomorrow, of any single hour of worry was never resting on your shoulders alone to begin with. The galaxy has been quietly managing itself for over 10 billion years without asking your permission or your help. It will keep managing itself while you sleep. There is a peculiar comfort in mattering less than you assumed. It means you can finally stop racing. And the giant, 20,000 light years off in Scutum, is having its own quiet version of the same experience, if a star can be said to experience anything at all. It doesn't know it's the size of 10 billion suns. It doesn't carry that number around like a burden or a badge. It just breathes, slowly, unevenly, the way it has breathed for a few 100,000 years, and will breathe for a comparatively short while longer, entirely indifferent to whether anyone below ever measures it correctly. The not knowing isn't a flaw in the star. It's simply how the star gets to exist. Unweighed, unranked, unbothered by comparison. Tonight, drifting towards sleep, you're allowed to borrow that same not knowing for yourself. You don't need to know exactly how you measure up against anything. You don't need the number. You only need the rest that comes from setting the measuring stick down. There's a tenderness in this that's easy to miss if you only look at the raw scale of it. 1 million Earths, 10 billion suns, 400 billion stars, because those figures, said quickly, sound like they're built to overwhelm you. But said slowly, the way we've been saying them, they do something gentler. They keep converting size into stillness. The bigger the number gets, the quieter the feeling that arrives with it, until by the time you reach the scale of the whole galaxy, the appropriate response isn't awe in the sense of being struck or overpowered. It's closer to the feeling of lying back in water that's exactly the right temperature, weight lifting off you as the water takes it. The universe is not asking you to be large. It's inviting you to notice how good it feels to be small inside something that doesn't need you to prove anything. And here, at the bottom of all this counting, is a small and rather lovely secret. One that the astronomers themselves will admit to if you catch them at the right hour, unhurried and honest, even they don't truly know how large this giant is. Not exactly. Not the way you might know the length of a hallway or the height of a familiar doorway you've walked through 10,000 times. The number, 10 billion suns, 2,150 solar radii, is their best patient guess, refined again and again across decades of careful looking, and still soft at the edges, still a little unfinished, still open to revision the way a story is open to revision each time someone remembers it slightly differently by lamplight. That not knowing isn't a failure of measurement, and it isn't something to feel unsettled by. It's almost the whole point of the night. If even the people with the largest telescopes and the most patient instruments have to shrug a little at the giant's true edge, then you, lying here with nothing but your own tired mind, are allowed every bit as much grace when the day's uncertainties refuse to resolve themselves before sleep arrives. The giant's true size has always been a little out of reach, a little beyond the edge of what any instrument can pin down for certain, and it's toward that soft fog-edged uncertainty, toward the place where even the most careful counting has to admit it doesn't quite know, that we drift next. And that breath, that endless giving away, is a fine place to remember something the giant has known all along, without ever needing to say it. It has no edge to speak of. A body made of mist does not end the way a stone ends. There is no wall, no rind, no clean line where star stops and not star begins. The gas simply thins and thins again, fading outward the way lamplight fades into an evening street, bright beneath the lamp, then dim, then indistinguishable from the dark it was always leaning into. So when we say a star is this wide or that wide, we are not measuring an edge. We are choosing one, deciding, by some patient agreement among people with telescopes, how faint the fog has to become before we stop counting it as star and start counting it as space. Move that decision a little, and the whole giant seems to grow or shrink beneath our hands, even though it never moved at all. Try, for a moment, to hold that thought the way you might hold a lantern up to smoke. Where does the smoke become room? And where is it yet lantern light caught in the air? There is no honest line to draw. Any astronomer measuring a red hypergiant is really making the same low-key decision over and over, agreeing, by convention, that the fog counts as star down to some faint threshold of brightness, and beyond that threshold, calling it sky. Move the threshold by a whisper, and the whole reported width breathes in or out by hundreds of millions of kilometers, though the star itself has not shifted a single atom. It is less like measuring a boulder and more like measuring the reach of a candle's glow across a dark room, real and warm, and entirely dependent on how dim a light you are willing to keep calling light. There is a second uncertainty tucked inside the first, and it is even quieter, even easier to miss. We cannot always agree, at first, on how far away the giant is. Distance is the ruler behind every other ruler. A star's true width can only be known if we know both its angular size, how wide it appears against the sky, and how far off it sits, because the same sliver of arc, held far away, is an immense thing, and held close is a modest one. Get the distance wrong by a little, and the size comes out wrong by a lot. This is not a flaw in the giants. It is simply the nature of measuring something enormous from very, very far away, with light that has traveled millennia to reach a lens the width of a dinner plate, through thousands of light years of the very dust that made this journey feel like passing through fog in the first place. And so, over the decades, as our distances have sharpened, some of the largest stars in our records have quietly changed size, not because they moved, or breathed out, or shrank, but because we finally saw them a little more clearly. Think of it as correspondence rather than error. Each generation of astronomers writing a kinder, more careful letter to the last, correcting a figure here, softening a claim there, never once accusing the giant of having misled anyone. Consider a giant that once wore the crown Stephenson 218 now wears tonight. For years, a red hypergiant named Scuti, also drifting somewhere in the hazy country of the constellation Scutum, a near neighbor to the giant you have been visiting, held the record for largest known star, estimated at something like 1,700 solar radii, a width so vast it strained comfortable comparison. Astronomers loved it the way you might love an old photograph, fondly and provisionally. Then, the Gaia satellite arrived, a spacecraft built for nothing but patient, careful distances, charting the tiny apparent shifts of 1 billion stars as Earth swings around the Sun, and it refined how far Scuti truly sits from us. The distance came in different from the earlier estimate, and with it, the size folded inward. Newer figures place Scuti closer to 750 solar radii, colossal even now, a body that would reach out past Jupiter if it sat where our Sun sits, though no longer the record it once was thought to hold. Nothing about the star itself changed in that revision. It simply exhaled, in our understanding, from an almost unthinkable width into a merely staggering one. The star never knew it had been demoted. It kept doing exactly what it had always done. There is a gentler story yet, from farther away, a red supergiant named WOG-64, out in the large Magellanic Cloud, one of the small satellite galaxies that drift near our own like companions, keeping a slow, respectful distance. For a long while, WOG-64 was spoken of as one of the largest stars known, wrapped, as many of these giants are, in a thick cocoon of its own shed dust. The slow snowfall of matter these stars breathe outward over tens of thousands of years, settling into a shroud around them. When the Very Large Telescope's interferometer, an instrument that combines several telescopes into one enormous compound eye, finally resolved that cocoon in detail, astronomers found that some of the glow we had been attributing to the star's own surface was in fact the dust around it, warmed and radiating on the star's behalf. Peel that borrowed light away, and the star inside is smaller than once believed, no less remarkable, no less a giant, but wearing a slightly smaller true shape beneath a slightly oversized coat. It is, if you let it be, a rather tender kind of story. A star was never quite as large as we thought, because part of what we were seeing was the warmth it had already given away, glowing faintly around it even now like breath on a cold window. And there is a third giant worth naming in this same tender company, Canis Majoris, another red hypergiant, sitting in the constellation of the Great Dog, once rumored in some very early estimates to be almost impossibly vast, larger even than the widest orbits of any planet we know, a number so large it seemed to strain the idea of a single star. Careful, repeated measurement has since settled it into a size near 1,420 solar radii. Even so, one of the largest stars we know of. Even so, a body that would swallow the orbits of the inner planets and reach out toward the giant planets beyond. But settled, the wildest early numbers softened, over patient years of ray observation, into something the evidence could actually hold, the way an exaggerated memory softens gradually into an account you can trust. None of this should feel like disappointment, the way a shrinking record might in some other kind of story. A sports record broken and then quietly asterisked. a claim that turns out overstated. It is not that kind of story at all. Every one of these giants remains, by any human measure, almost incomprehensibly enormous. What changed was never the star. What changed was the sharpness of our looking. And that is worth sitting with for a moment, unhurried. The record books of the universe's largest stars are not a scoreboard. They are something closer to a loose collection of fond, careful guesses, revised again and again as our eyes improve, each revision a small act of honesty rather than a small failure. Stephenson 2:18 itself, the giant you have been visiting tonight at roughly 2,150 solar radii, carries its own wide margin of uncertainty, its own soft asterisk waiting, perhaps, for the next spacecraft, the next telescope, the next careful remeasuring of the dust and distance between here and Scutum. It may hold its crown for decades. It may not. Either way, it will not notice, and neither, tonight, do you need to. This is, in the end, the same lesson its whole gaseous, breathing, ember-lit body has been offering since the beginning of this visit. A thing this large has no firm edge to be certain about, and so certainty was never really the point. The giant does not know its own size, and now you know something gentler yet, that we do not fully know it either, and that nothing at all is lost in that not knowing. The number is a kindness we offer each other, an agreed-upon place to stop counting the fog, not a verdict carved into the star itself. It glows on regardless, indifferent to our tape measures, patient with our revisions the way it is patient with everything. Which leaves one small, warm curiosity before rest can fully take you. If a star like this has no edge, and sits so many thousands of years of light away, and hides itself behind dust the way a lamp hides behind fog, how did anyone ever come to measure it at all? How did a scattering of patient, ordinary people, looking up from an ordinary planet, ever piece together enough to say, there, in that faint smudge near Scutum, sits the largest thing we have found? That story, too, is a slow one, and it is the one still waiting, low and unhurried, on the other side of this breath. And if the giant itself keeps no ledger of its own size, then someone else had to keep one for it, patiently, across a whole human lifetime of nights. That is where we drift now, away from the star's misty edge and toward the small, warm rooms where people first noticed it glowing at all. It began, as so much of this knowledge does, with one person looking where almost no one else thought to look. In 1990, an astronomer named Charles Stephenson was working through the results of an infrared survey of the sky, the kind of survey built to catch light too red and too cool for the eye, or for ordinary photographs to register. Light that a giant like this one gives off in abundance, since a body glowing at only a few thousand degrees speaks mostly in a wavelength older, warmer instruments were never built to hear. Buried in the direction of Scutum, in that dust-thick seam of the galaxy where visible light gets swallowed almost as soon as it's born, he found a cluster of stars glowing unusually bright in exactly that infrared window. It would come to carry his name, Stephenson 2, a quiet echo of one evening's careful attention still hanging in the sky decades later, the way a single kind word can outlast the person who said it. He wasn't hunting for a record. He was only reading the data closely enough to notice that something there was strange, and strange in a particular, patterned way. The way a good listener notices when a familiar voice sounds slightly different tonight. That noticing was the whole beginning. Before that moment, and for a long stretch of astronomy's history, this is how it always went. Not with instruments reaching out and grasping an answer, but with instruments slowly getting better at simply receiving what was already arriving, night after night, uninvited and unhurried. The earliest of these records were photographic plates, sheets of glass or film coated in light-sensitive emulsion, carried out to a telescope, exposed for long minutes or hours while the star's faint light etched itself into silver grains, then carried back inside, developed, dried, filed away in wooden drawers that still exist in observatory basements today. Thousands upon thousands of them, each one a single held breath of sky. An observer in an earlier decade might spend a whole cold night simply making sure the telescope stayed pointed at the same patch of scutum, while the plate quietly gathered starlight, no faster than the star was willing to give it. There was no rushing that. The plate took what it took, and in that slowness there's something worth resting in tonight. The idea that understanding never demanded urgency from the universe, only attention, and that attention, given consistently enough, eventually adds up to knowing. Photographic plates gave way, in time, to electronic detectors, more sensitive, more patient in their own way, able to hold a fainter signal without losing it to noise, and those in turn gave way to telescopes lifted clear of the atmosphere entirely, up where the air's own restless shimmer can no longer blur or steal a fraction of the light. Each generation of instrument didn't so much replace the one before it as continue its sentence, finishing a thought that a plate in a wooden drawer had only begun to whisper. And among the newer instruments, one deserves to be named the way a favorite grandparent might be named at a bedtime story: Gaia, a spacecraft launched to do one enormous, patient job, to sit in a stable orbit and, for years on end, measure the tiny apparent shift of more than 1 billion stars as Earth carries it from one side of its orbit to the other. That shift is called parallax, and it's a wonderfully humble kind of magic. Hold a finger out at arm's length, close one eye and then the other, and watch the finger seem to hop against the background. The closer the finger, the bigger the hop. Gaia does exactly that trick. At a scale of light years, watching stars hop by fractions of an arcsecond too small to ever notice with the naked eye. And from that hop alone, distance falls out of the mathematics, like fruit dropping from a low branch. And distance is the quiet keystone under everything this whole night has described. Change how far away a star is thought to be, even slightly, and you change how large it must be to look the brightness it looks from here, which is exactly why some of these giants have grown or shrunk in the record books, not because the stars themselves changed, but because our ruler, our sense of how far the light had to travel, was gently corrected. The star was never wrong. We were only for a while holding the tape measure a little unevenly, and Gaia has spent years easing it straight. And then there is the matter of actually seeing the giant's shape, not just its light as a single dimensionless point, but its shoulders, so to speak, the true tiny disk it presents to us across thousands of light years, ordinarily far too small an angle for any single mirror on Earth to resolve. However large that mirror is built, for that, astronomers built something closer to a trick of teamwork than a single instrument: several enormous telescopes, spaced far apart on a mountaintop, their light combined and compared with such exquisite timing that together they behave as one telescope the width of the whole array. This technique, interferometry, is how observatories like the Vlalet, a cluster of giant telescopes set high and dry above the shimmer of lower air, have managed, on certain still and cooperative nights, to resolve the actual outline of a red hypergiant's disk, to trace the fog of its true edge the way you might trace a friend's face through a steamed window, patient stroke by patient stroke, until the shape agrees to be seen. It is delicate work. It asks for a calm atmosphere, a well-behaved instrument, and a great deal of care in combining signals that could easily blur into nonsense if rushed. But when it succeeds, it hands us something almost tender, a real look, however soft-focused, at the actual skin of a star none of us will ever touch. Every such measurement is really a small act of trust. Trust that the mirrors were aligned correctly, that the air stayed cooperative, that the faint signal traveling those thousands of light years arrived honest and unbroken. Astronomers check it, and check it again, and only then let themselves believe the number they've found. And behind every one of these grand instruments, quietly, there have always been ordinary observers doing the plainer, slower work that makes any of it possible at all. Variable star watchers logging a star's brightness night after night for years, sometimes for whole careers, sometimes handing the same target across generations, one notebook closing and another opening in a different hand, a different decade, the same patient question carried forward. Somewhere in an archive there are ledgers that begin in one observer's careful pencil and end, chapters later, in a grandchild's, tracking the same slow pulse of some ember-red giant rising and dimming, across a span of human lives longer than the star itself will ever notice passing. None of them were in a hurry. None of them needed to be. The star wasn't going anywhere, and their only task was to keep showing up, keep writing the number down, keep trusting that the pattern would eventually speak if given enough nights to say it. That is, in its own way, exactly how you are learning tonight. Not by force, not by demand, just by lying still and letting information settle over you the way starlight settles over a dark field, arriving on its own unhurried schedule, asking nothing back. So this is how a species with such small, warm, short lives came to know anything true about a body so vast. It barely notices its own shape, not in a single flash of discovery, but in layers. One man's eye catching an odd glow in a stack of infrared plates, a billion careful parallax measurements refining a distance, a mountaintop full of mirrors learning to act as one enormous eye, and, underneath all of it, decades of quieter hands writing down brightness after brightness after brightness, never once expecting to finish the job in their own lifetime. Knowledge, built this way, doesn't arrive like a light switching on. It accumulates the way sleep accumulates, in small unclaimed minutes, in things absorbed without straining for them, until one day you simply find you know. And somewhere above Scutum right now, entirely unaware of any of this careful human attention, entirely unaware of its own staggering size, the giant is still there, still glowing that same deep ember red it has glowed for longer than any observatory has existed, unmeasured in any way that matters to it, unbothered by every revision we've ever made to its number. It doesn't need us to have the size right. It only needs to keep being, quietly, itself. And you, here, now, don't need to have anything figured out either, not the number, not the distance, not even tonight's thoughts fully resolved. You only need to keep being, quietly, yourself, a little longer, as the night thins and settles and grows very soft around you. Tonight has been about a question that never really needed an answer to be worth asking. What is the largest star ever found? And about letting that question loosen in your hands instead of tightening around it. Tonight has been about standing on ordinary ground, under an ordinary roof, and understanding that largest is not a wall we run into, but a thread we get to follow for as long as we like, and can drop at any moment without losing our place. Tonight has been about traveling, without moving, out to a hazy cloud of stars near the constellation Scuti and finding Stevenson 218 waiting there. A body so wide that its own light needs hours to travel from one side to the other, and yet none of that vastness asked anything of you except to notice it, briefly, and then let it go. Tonight has been about watching a star grow old the way a tide moves, swelling outward across spans of time too long for any clock we own, its outer layers thinning into something almost like breath, joined by a hushed scattering of cousins doing the same slow work in other corners of the galaxy. And tonight has been about sitting inside, not knowing. About scientists with careful instruments, still disagreeing, gently, on exactly how wide this giant really is, and about how that disagreement is not a gap in anyone's understanding, but simply the shape uncertainty takes when something is too enormous to fit inside a single tidy number. None of this needs anything from you tonight. Not memory, not attention, not even belief. The thread of light we followed out towards Stevenson 218 is still out there, unspooling in the dark exactly as it was before you ever heard its name, and it will go on doing that long after you've forgotten every word of tonight's journey, which is, in its own way, a kind of relief. You were never the one holding it up. You only got to notice it drifting by. If your eyes are already closed, or close to it, you don't need to open them. Another quiet exploration is already waiting on the screen nearby, and you can simply let it begin on its own, the way one wave follows another without needing to be asked. There's nowhere you have to be for that to happen. Here is one small thing you could carry into sleep if you want it, though it needs no answer from you, now or ever. Somewhere on a night sky you've stood under before, unnoticed, has been a star large enough to swallow the distance between here and somewhere you call home many times over, and you never had to feel its size to be safe underneath it. Let that sit there, unanswered, the way a stone sits at the bottom of a quiet lake. Feel the weight of the blanket again, wherever it's resting on you now. Feel your breath slow on its own, without you steering it, the way it always eventually does. Feel the small distance between your body and everything enormous we spoke about tonight, a distance so wide, so forgiving, that none of it, not the giant, not its hours-long light, not its uncertain edges, was ever close enough to reach you. You are here. You are small in the kindest possible way. The way a person is small standing at the edge of an ocean they don't need to swim across tonight. Let your thoughts loosen the way a hand loosens when sleep finally arrives before permission is even given. There is nowhere else you need to drift to from here. Sleep well.